Now next point, that is expression for torque acting on the body. Torque. What is torque? It is also kind of the force, but the force which tends a body to move. Now see, this is a body. I am applying a force here. Okay, whatever the force I am applying, same kind of force it is getting from here. Okay, equal and opposite force it is getting from here. As a result, this duster is starting its motion to rotate. Okay, which helps a body, the force which helps a body to rotate is called as torque. And this torque, when torque is applied, so now I am holding this duster here, so axis of rotation is this center. Okay, axis of rotation is this. Now this distance is nothing but radius. Whenever I am applying the force here, okay, this distance is equal to this, it is symmetrical, so equal force it is getting from downward, so that these two force makes a duster to, okay. So torque is a vector product of force into radius vector. Torque is a vector product of force into radius vector. Okay. Now we are going to derive the expression for torque. Again we have to consider the same figure. Only slight changes are there here. Okay. Consider a body having n number of particles on it. Okay. And the body is moving with constant angular acceleration alpha. Body is moving with constant angular acceleration alpha. Okay, it consists of the particle each having mass m1, m2 and mn, and they are situated at distance r1, r2, rn respectively from this axis of rotation. First particle having mass m1, distance is r1, second particle having mass m2, distance is r2, and particle having mass mn, distance is rn from this axis of rotation. Okay. Now as it is body is moving with constant angular acceleration, so we have to derive linear acceleration, and we have the formula for linear acceleration. What is the formula? Linear acceleration A is nothing but r alpha. We have studied it in initial part of this chapter, while we have studied velocity, relation between linear velocity, angular velocity, acceleration, relation between linear acceleration and angular acceleration. A is equal to r alpha. So the linear acceleration of first particle, let it be a1, so it will be nothing but r1 alpha. Of second particle is a2, that is equal to r2 alpha. Similarly of nth particle is an is equal to rn alpha. Okay. Now by Newton's law of motion, we know that what is Newton's law of motion? Force is equal to mass into acceleration. So force acting on first particle F1 is nothing but equal to m1 into a1. So m1 a1, that is nothing but m1 r1 alpha, because what is value of a1? r1 alpha. So I just put here m1 r1 alpha. Similarly force acting on second particle is m2 a2, that is nothing but m2 r2 alpha. Similarly force acting on nth particle is mn rn, that is nothing but mn rn alpha. Okay. Now we have to find the torque. What is torque? Torque is vector product of radius vector and force. Okay. So r f, that is nothing but r cross f, that is nothing but rf sin theta. But again here if you see, this is an acceleration, this is a particle, so this is the radius and this is acceleration. So angle between radius and acceleration is 90 degree. Okay. So as theta equal to 90 degree, what we get? Sin 90 equal to 1, and as sin 90 equal to 1, we get torque is equal to rf. Torque is equal to rf. So torque acting on first particle is r1 f1. So put value of f1 here, r1 into f1. F1 is m1 r1 alpha. So when we multiply, what we get? m1 r1 square alpha. Similarly of second particle, we have r2 f2, that is nothing but equal to r2 into m2 r2 alpha, that is equal to m2 r2 square alpha. Similarly of nth particle, we have rn fn, that is nothing but equal to rn mn into rn alpha, that is nothing but mn rn square alpha. Now this is the torque which is acting on individual particle. Now total torque acting on body is nothing but summation of all these torques. So total torque tau is nothing but equal to tau 1 plus tau 2 plus dash 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 tau n. This letter is called as tau, Greek letter tau. Okay. So just put the value of tau 1. What is tau 1? M1 R1 square alpha. What is tau 2? M2 R2 square alpha. Similarly, tau n is Mn Rn square alpha. Now, what is common here? Alpha is common, so I have taken outside. So what is remaining? M1 R1 square plus M2 R2 square dash 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 plus Mn Rn square. Okay, and this we can replace by a summation sign. That is summation I is equal to 1 to n mi ri into alpha. Okay, now this term is called nothing but moment of inertia, that is I. So tau is equal to R alpha. This is a formula for torque acting on rotating body. Okay, note down this.